Students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing the numericals of EMI. Let's see this. The magnetic flux associated with a coil changes by 5 into 10 raised to minus 2 Webers in 25 seconds. Find the EMF induced in the coil. Find the EMF induced in the coil. EMF is nothing but rate of change of flux, so it's d phi by dt. Straightforward, you have the data, you can substitute and get the answer. The answer for this should be 0.2 into 10 raised to minus 2. That is going to be the EMF volts that will be induced in the coil. Next, take on next sum please. The flux associated with a coil changes from 4 into 10 raised to minus 2 Webers to 0 Webers in 20 seconds. Find the average EMF induced in the coil. Find the average EMF induced in the coil. Change in EMF, that's phi 2 minus phi 1 upon T, right? Negative phi 2 minus phi 1. Why negative? Remember I had explained this to you in theory that the induced EMF opposes the very source that produces the EMF, therefore that negative sign, right? So you have the values, you can substitute and get this answer. The answer for this should be 2 into 10 raised to minus 3 volts. Answer should be 2 into 10 raised to minus 3 volts. Next, take down next one please. The magnetic flux associated with a coil changes from 0 to 6 into 10 raised to minus 2 Webers in 0.6 seconds. Find the average EMF. Find the average EMF induced in the coil. Find the average EMF induced in the coil. Replica of the previous sum, same formula. Final flux minus initial flux upon time. The answer for this sum should be 10 into 10 raised to minus 2 volts.
The answer will be negative.
Yeah, the negative sign only indicates that the direction of the applied EMF and the induced EMF is going to be different, right? What is producing the flux? The EMF that is producing the flux and the EMF that is induced are going to be in opposite direction. That's what the negative sign signifies.
So in the answer, you can either the negative sign indicates that, or we can just
No, you don't write the negative sign. That is only for you to know that that's for the direction. Okay. Yes.
In the first term, we did not write E is equal to minus d phi upon dt.
Because in that case you have just the EMF. I've just found out the magnitude of EMF. The correct formula should be minus d phi by dt, but here I'm only interested in the magnitude of EMF. Next, a coil has an area. A coil has an area of 0.5 meter square. A coil has an area of 0.5 meter square and 1000 turns. Is kept in a magnetic field. Is kept in a magnetic field of 0.05 Webers per meter square. Is kept in a magnetic field of 0.05 Webers per meter square. Calculate the change in flux. Calculate the change in flux if the coil is rotated through 0 degrees, through 60 degrees. The coil is rotated through 60 degrees about one of its diameter. The coil is rotated through 60 degrees about one of its diameter in 5 seconds. The magnetic field was initially perpendicular to the coil. The magnetic field was initially perpendicular to the coil. Find the average EMF induced. Now, first let's find out the change in flux, d phi. Change in flux is nothing but phi1 minus phi2. Should be minus phi2 minus phi1. I'm not writing the negative sign, so therefore I'm writing that as phi1 minus phi2, which can be written as NAB cos theta 1 minus NAB cos theta 2. So this is going to be nothing but NAB cos theta 1 minus cos theta 2, right? Once you have this, you will know the change in flux. They've also given you the time, so you can find out the induced EMF. The induced EMF is going to be d phi by dt. You know the value of d phi, NAB cos theta 1 minus cos theta 2, and you know dt, time is 5 seconds, you should get the answer. The answer for this sum should be 2.5 volts. Next, take down next one please. A rectangular coil.
NAB cos theta 1 minus cos theta 2. Then we find that and then we find.
Yes, you will find the value of this and then you will get your EMF. A rectangular coil. A rectangular coil of length. A rectangular coil of length 0.5 meters and breadth 0.2 meters has a resistance of 10 ohms. Has a resistance of 10 ohms. The coil is placed in a magnetic induction. The coil is placed in a magnetic induction of 0.05 Webers per meter square. 0.05 Webers per meter square, and its direction is perpendicular to the plane of the coil, and its direction is perpendicular to the plane of the coil. If the magnetic induction is uniformly reduced to zero, if the magnetic induction is uniformly reduced to zero in 10 raised to minus 4 seconds, find the EMF and the current induced in the coil. Find the EMF and the current induced in the coil. Find the EMF and the current induced in the coil. EMF is change in flux upon time, right, which is nothing but A into initial magnetic induction, final magnetic induction upon time, right? You know the initial magnetic induction, you know the final magnetic induction. I can say that A, since it's a rectangular coil, will be nothing but length into breadth, right? So I'll come to know A, I know B1, I know B2, I can substitute and I can get the value of EMF, right? Once I get the value of EMF, then I can say that current, Ohm's law, E upon R, they give you the value of resistance, you know the EMF, so you will know the current that will be induced in the coil. The answer for this sum should be EMF is 50 volts and current is 5 amps. Next, take down next one please. A coil has 50 turns. A coil has 50 turns and an area of 800 centimeters square. And an area of 800 centimeters square. Is held with its plane perpendicular, is held with its plane perpendicular to a uniform magnetic field, is held with its plane perpendicular to a uniform magnetic field of induction 5 into 10 raised to minus 5 Webers per meter square. Is held with its plane perpendicular to a uniform magnetic field of induction 5 into 10 raised to minus 5 Webers per meter square. If it is pulled out of the field in 2 seconds, if it is pulled out of the field in 2 seconds, find the EMF induced in the coil. Find the EMF induced in the coil. Find the EMF induced in the coil. It was initially placed in a magnetic field of induction 5 into 10 raised to minus 5. If it is pulled out of the magnetic field, that means my final magnetic field that will be acting on it will be 0. Once I have this, then I can say EMF is change in flux upon time, which is going to be nothing but A into B1 minus B2 upon T. But there are n number of turns, therefore this will be n times A B1 minus B2 upon T. Right? You have all the values. All you need to do is substitute and get the answer. The answer for this should be 10 to the power of minus 4 volts. Next, take the next one please. A square wire loop, a square wire loop of side a square wire loop of side 0.5 meters is placed with its plane perpendicular to the magnetic field, is placed with its plane perpendicular to the magnetic field if the resistance of the loop is 5 ohms, find the rate at which the magnetic induction should change. Find the rate at which the magnetic induction should change so that a current of 0.1 amps is induced in the loop. So that a current of 0.1 amps is induced in the loop. Length of the square loop is given, so I can find out area of the square loop. Area will be L square, that's 0.5 into 0.5. So you will come to know the area of the loop. Now they are saying that current is given to you. So in that case I can say that E is equal to IR. Resistance is given to me. So I'll come to know the EMF that is going to be induced in the loop. But we know that EMF is equal to A times B1 minus B2 upon T, which could also be written as A times change in magnetic field upon T, right? In which case I can therefore say that E is also equal to, so I can therefore say that E upon A is change in magnetic field upon change in time, dV by T. Change in external magnetic field upon time is nothing but the rate of change of flux. So rate of change of flux will be equal to E upon A. E I already know from here, A also I know. I can divide and get the answer. I should get this answer as d phi by dt should be equal to 2 Teslas per second. Next, take on next one please. A metal rod of length 1 meter, a metal rod of length 1 meter is rotated about one end in a plane at right angles to a uniform magnetic field of induction (2.5 into 10 raised to minus 3 Webers per meter square). If it makes 1800 RPM, calculate the EMF induced between its ends. Calculate the EMF induced between its ends. Now guys, let's try to see this. This is the metal rod. This end I'm going to keep fixed. The other end I'm going to rotate. The sum says that a metal rod is rotated about its one end in a plane at right angles to a uniform magnetic field. You have uniform magnetic field of induction B over here, right? In which case I can therefore say that I have to find out the EMF that is induced in the coil. Now, induced in the rod. I can say that what is in one rotation, what will be the area traced by the circle in one rotation? In one rotation, area traced out by the rod will be pi r square, where r will be the radius of the circle, right? That will be the area that is going to be traced out by the rod in one circle, right? Now, in that case, what will be the area traced by the rod in n number of circles? If this is the area traced by the rod in one circle, then the area traced by the rod in n number of circles, area traced by rod in n rotations will be n times pi r square. Fine, do we get this thing clear? Now, once I have this, then I can say therefore the change in area is n times pi r square, right? Now, change in flux in n revolutions will be nothing but area traced in n revolutions multiplied by the magnetic induction. Area traced in n revolutions, change in magnetic flux is d phi. Area traced in n revolutions is n times pi r square into b. That is going to be my change in flux, right? This is the area that is going. This is going to be my change in flux per second, because this is going to be the area that is traced in per second. I can say that as this area is traced in 1 second, therefore I can say that the change in time is 1 second. How do I know 1 second? Because I have converted revolutions into RPS, and we know that EMF is change in flux upon time. We already know change in flux is n pi r square b upon dt. Right, substitute the values, you should get the answer for this. You should get this answer as EMF is going to be 235.7 into 10 raised to minus 3 volts. Right? Next, take down next one please. A metal rod 1 upon root pi, a metal rod 1 upon root pi meters in length, a metal rod 1 upon root pi meters in length is rotated about one of its ends, in a plane perpendicular to the magnetic field of induction to a magnetic field of induction 5 into 10 raised to minus 3 Webers per meter square. Calculate the number of revolutions the rod makes per minute. Calculate the number of revolutions the rod makes per minute if the induced EMF is 15 millivolts. If the induced EMF is 15 millivolts. Straight, very similar to the previous one, I can say that area traced in one revolution. Area traced in one revolution is going to be pi r square. Therefore, area traced in n revolutions will be n times pi r square. That will be the area that is going to be traced in n revolutions. Now, the change in flux is nothing but area traced into the magnetic induction. So the change in flux is area traced n pi r square into magnetic flux B. Right? Now let us assume that this is the area traced in 1 second. Let this be the change in flux per second. Therefore, I can say that dt is going to be 1. EMF is d phi by dt. So I can say EMF is n pi r square b upon 1. Therefore, I can say n is equal to E upon pi r square b. That will be the number of revolutions per second. But the sum says that you have to find out the number of revolutions per minute. This is going to be my revolutions per second. So this will be E upon pi r square b into 60 to convert it into RPM. To convert it from RPS into RPM, you have to multiply by 60. The answer for this sum should be 180 RPM. Next, take down next sum please. A conductor has a length of 0.3 meters. A conductor has a length of 0.3 meters, moves with a uniform velocity of 10 meters per second. Moves with a uniform velocity of 10 meters per second at right angles to a magnetic field. At right angles to a magnetic field of induction. At right angles to a magnetic field of induction. At right angles to a magnetic field of induction, 0.5 into 10 raised to minus 4 Webers per meter square. Calculate the EMF induced in the conductor. Calculate the EMF induced in the conductor. EMF induced in the conductor is BLV, magnetic field, length and the velocity with which it is moving. You should get the answer for this straightforward simple sum. The answer for this should be 1.5 into 10 raised to minus 4 volts. Next, let's see another sum guys. A conductor moves with a velocity. A conductor moves with a velocity of 1.5 meters. Sorry, a conductor moves with a velocity of 10 meters per second. A conductor moves with a velocity of 10 meters per second in a magnetic field. A conductor moves with a velocity of 10 meters per second in a magnetic field of 0.6 into 10 raised to minus 4 Webers per meter square. The EMF induced in the conductor, is 3 into 10 raised to minus 4 volts. Find the length of the conductor. Find the length of the conductor. Right? EMF is equal to BLV. I know B, I know V. I can find out the length from here. The answer for this should be 0.5 meters. Right? Take on next one, please. The axle of a railway engine. The axle of a railway engine has a length of 1.5 meters. The axle of a railway engine has a length of 1.5 meters. Calculate the EMF that will exist between its ends. Calculate the EMF that will exist between its ends when the engine moves with a speed of 60 kilometers per hour. When the engine moves with a speed of 60 kilometers per hour and the angle of dip is 46 degrees. The horizontal component of the Earth's magnetic induction. The horizontal component of the Earth's magnetic induction the horizontal component of Earth's magnetic induction is 3.6 into 10 raised to minus 5 Webers per meter square. Now, they've given you the horizontal component of the Earth's magnetic field. Now the axle of the wheel is going to cut the vertical component of the Earth's magnetic field. Guys, this is the wheel. This is the axle, which is going to rotate this way. Right? So as it rotates this way, it is going to cut the vertical component of the Earth's magnetic field. I can say that the axle of the train cuts the vertical component of vertical component of the Earth's magnetic induction Therefore, I can say that I can use tangent law. If I use tangent law, I can say BV is equal to BH tan phi. That's my tangent law. So I'll come to know the vertical component of the Earth's magnetic field. Once I know this, I can find out EMF. EMF is nothing but BLV. Now since the axle is cutting the vertical component, I'll have to take BV, the vertical component of the Earth's magnetic field. The answer for this sum should be 9.325 into 10 raised to minus 4 volts. Next, take on next up please. Determine the induced EMF. Determine the induced EMF across the axle of a train, across the axle of a northbound train moving with a speed of 90 kilometers per hour. Northbound train moving with a speed of 90 kilometers per hour. If the vertical component of the Earth's magnetic field is 3 into 10 raised to minus 5 Tesla, and the length of the axle is 1.25 meters, and the length of the axle is 1.25 meters. Straightforward sum. EMF is BLV, right? Where I have the vertical component is given to me, length of the axle is given to me, and the velocity at which the train moves is also given to me. The answer for this sum should be 9.375 into 10 raised to minus 4 volts. Next, let's see the next one. If the RMS value of an alternating voltage is 230 volts, find its peak value. If the RMS value of the alternating voltage is 230 volts, find its peak value. ERMS is E0 upon root 2. That's the relationship between peak value and RMS value, right? If the RMS value of the alternating voltage is 230 volts, find the peak value. They've given you the RMS value. You can straight away calculate the peak value. The answer for this should be 325.22 volts. Next, take down next one please. If the peak value of an alternating voltage is 350 volts, if the peak value of an alternating voltage is 350 volts, calculate the RMS value. Calculate the RMS value. Again, very simple. ERMS is E0 upon root 2. Right? The answer for this sum should be 247.5 volts. Next, take down next one please. An alternating EMF E is equal to 100 sine 100 pi t is applied to a bulb of resistance 1200 ohms is applied to a bulb of resistance 1200 ohms. Calculate the RMS value of current, the frequency and the period of the AC, the peak value of current,
Frequency.
the frequency and the period of the AC, the peak value of current, and the RMS value of the EMF. Now they give you E is equal to 100 sine 100 pi t, but we know that E is equal to E0 sine omega t. Therefore, I can say that E0 is going to be 100 volts and omega is 100 pi, right? Okay, once I have this, then I can find out what did they ask me to find out. First thing they've asked me to find out RMS current, for which I need to know peak current. Peak current is nothing but peak voltage upon resistance, Ohm's law, guys, right? So I'll come to know my peak current from here. This is the first thing I'll find out. From this, I can find out my RMS current. IRMS is nothing but peak current divided by root 2. So I'll come to know RMS current. So that was the first part of the question. Next, they will ask you to find out the frequency and the period of the AC. Let's see this. They've given us that we know the value of omega. Omega we have said is 100 pi. Right, but omega is nothing but 2 pi f is 100 pi. From here I'll come to know that f is going to be nothing but 50 hertz. So I found out the frequency. Next they've asked me to find out the time period. Time period is 1 upon f. I've already found out the frequency, so I should get the value of time period. Last thing they've asked me to find out is RMS value. Peak value of current I've already found out. RMS value of EMF. ERMS is E0 upon root 2. I already know the value of E0. I should be able to get the value of ERMS. The answers for this sum should be I0 is going to be 0.083 amperes. IRMS is going to be 0.0587 amperes. Then frequency I've already found out. Time period should be 0.02 seconds, and ERMS is going to be 70.72 volts. Right? Take down next one, please. Right? A 25 watt lamp, is connected to an AC having a peak value of 100 volts. Calculate the RMS and the peak value of current. Calculate the RMS and the peak value of current. Now first of all I can find out ERMS. ERMS is nothing but E0 upon root 2. So I'll come to know my RMS value of EMF. Power in an AC circuit is nothing but ERMS into IRMS. Power is given to you, I know ERMS, so I'll come to know IRMS from here. Once I know IRMS, I can say IRMS is nothing but I0 upon root 2. From there I'll come to know my peak value of current. The answer for this sum should be IRMS is going to be 0.3535 amps and I0 is 0.5 amps. Right, next, take on next one please. A coil has 100 turns. A coil has 100 turns, each of area 0.02 meters square, is rotated in a magnetic field of 3.5 into 10 raised to minus 5 Webers per meter square. Calculate the maximum EMF induced in the coil. Calculate the maximum EMF induced in the coil if the number of revolutions are calculate the maximum EMF induced in the coil if the number of revolutions are 100 per second. If the number of revolutions are 100 per second. Very simple sum. E0 is nothing but 2 pi f NAB. NABF, everything I know. Straight multiplication. Very simple. The answer for this should be 43.96 into 10 raised to 3 volts. Next, a rectangular coil has dimensions 6 centimeters and 4 centimeters, has dimensions 6 centimeters and 4 centimeters, having 100 turns, rotates at 50 RPS and generates a maximum EMF of 6 volts. Find the magnetic induction. Find the magnetic induction. First of all, I can find out area. Area is nothing but length into breadth, right? Once I have this same formula, E0 is equal to 2 pi f NAB. They've asked me to find out B, so I can say B is equal to E0 upon 2 pi f NA. A I know, F, N, E0 I know. All the values I know, I should be able to get the answer for B. Answer for this sum should be 7.962 into 10 raised to minus 3 Webers per meter square. Next sum. A coil has 10 to the power of 3 turns. A coil has 10 to the power of 3 turns, each of area each of area 100 centimeters square, each of area 100 centimeters square, rotates with a speed of 100 rpm, rotates with a speed of 100 rpm in a magnetic field of 3.6 into 10 raised to minus 2 Webers per meter square. Find the peak and the RMS value. Find the peak and RMS value. Find the peak and the RMS value of the induced EMF. Right? Peak value of induced EMF. They've given you area, they've given you the frequency B and A. So I can say peak value of EMF is 2 pi f NAB. Once I have the peak value of EMF, then I can say RMS, ERMS is E0 upon root 2. So that will give me my ERMS. The answer for this sum should be E0 is 3.768 volts and ERMS is 2.665 volts. Right? Okay, we'll stop this here for the day. Thank you very much.